maximum product subarray. Got no submissions, got no submissions. Find minimum in rotated sorted array. Balls. At least I think there are no hard ones. I think they're just mediums. So that's kind of good, I guess. I think I already did maximum subarray, so maximum product subarray. Did I already do that one? Yeah. So I already did maximum subarray, so going to do 152 maximum product subarray. Maximum product subarray. Product of array except self. I already did that one. All right, cool. This is the one. 152 maximum product subarray. Make a note of that before I dive in. I just want to remember. Currently on. Cool. Just making a note of that. All right, y'all. Tuning in. This is like part 3. I'm trying to grind through the line 75. Currently on maximum product subarray. I'm just doing these in order from top to bottom. That's just how I'm doing. I'm not like suggesting that's optimal. Okay, so let's read this prompt. Prompt is, given an array of numbers, find a contiguous non-empty subarray within the array that has the largest product and return the product. Okay. A subarray is a continuous subsequence of the array. Cool. So this is similar to maximum subarray, yeah, except it's a product instead of adding. This one was considered easy, and the solution used Kadane's algorithm, I think. Kadane's algorithm, dynamic programming. So my intuition says, hey, follow the same pattern. Let's think through if there are any issues with that. So let's suppose we take a dynamic programming approach, and we're constrained that it's going to be between -10 and 10. Okay, so I can get some zeros, for example. Yeah, so how we did this previously is we just basically did a rolling addition, a rolling sum. And we always took the maximum. Always take the maximum. So either the current value as you pass through the index in the array, either take the current value if it's greater, or take the product of it with the previous accumulation. That's my naive solution. Okay, so naive solution is follow Kadane's algo, like max sum. Have that is take subarray products and use math.max at each increment. Have a super max outs that doesn't reset So the time on this, time O of n, I believe. Yeah. And space, can I do it in constant or is it also O of n? I think it is constant time because I'm just holding the product. Like the current subarray product and also the supermax. So that's what I think, but let's keep going and we'll see. So let cur product, we're gonna have that be, we're gonna initialize that to 1 so that we can multiply by it. And then we will also let like all time max equal 1. We need to do negative infinity so that anything will be bigger than it because we could go down to negative 10. Okay. And then, so we have the current product, we have the all-time max. I think that's all we need for now. So we'll eventually return all-time max. Initialize a for loop right here. Cool, just got a basic for loop going on. Current value. Is the ith index of nums. Okay. So I guess the trick here would be double negatives, wouldn't it? Okay, so that will be a gotcha. Okay. Another edge case would be zeros. Okay. So the math.max is either the all-time max or the cur value. Okay. Nope, that's the cur product times cur value. Cur product times cur value or cur value. And all-time max equals math.max of cur product or all-time max. Okay, cool. So What if there are two cases that are both the largest product equally? Since the output is just a number, you can still return that value. If there are two cases that have the largest product equally, we don't need to know the indices. Okay. So this is going to fail in certain cases. What case will this fail in? Let's come up with a test case where it will fail. Do we pass the examples? Example 1 and 2. So let's look at this. Example 1, we start with 2, we get 6, and then this becomes negative 12. We would take negative 2 over negative 12, and then we would take 4 over negative 2. Okay. This one we would take 0. Now let's consider like the inverse of this, because I want a couple negative. I want negative, negative, positive, negative, negative, positive, negative, negative. Yep. All right, so let's do another test case. So we'll flip these signs. So negative, negative, positive, negative, negative. Okay, and the trick here is that we want to multiply all of them, right? Because two negatives make a positive. Whoop, whoop. So here we got 6. Hey, Jess. Hey. Could you take Tina a bag of ice? Like ice in a baggie? Thank you. So this would be negative 2 times negative 3. Would be 6 times 2 is 12. And then we would say, hey, 12 times negative 4 is minus 48. And minus 4 is less negative than minus 48. So we would want to pick minus 4. Where are the bags? I kind of thought they were right here. Can you ask Tina? Thank you. So our current implementation would take the minus 4, but that's not correct because then we can only get to minus 20. Whereas if we retained all the above, we could get to like a lot bigger of a number. So there's current product, and then I also kind of want to do like per non-zero product. So I basically want to have like a third. I'm not sure this is the optimal solution, right? But I want to have a third that says, hey, don't give up because you might run into another negative. So here's cur product, and then this. Throw that in there. So this is just going to be cur product. We're just gonna always increment this. It's a product increment. We're gonna always increment that one. Now, a trick is if it becomes 0, that's like a problem. Because it will be stuck on 0 forever, right? So in this case, I don't have to worry about it, but say that one of these is 0. We initialize it to 1, so the question is whether cur value is 0. So I can just do if cur value is 0. Else. So we'll reset it back to 1. Okay, so this will, if we run into a 0, we're going to set this back to 1. And if it's not a 0, we will continue to multiply. So here we go, -2, 6, right? And it accumulates and it gets the bigger one. Now the problem is that we can't always use this guy. So consider another test case, which is just 0, 0. This would have us returning 1. Which is larger than the true answer. The true answer would be 0. I think it's a special case where the value is 1. So consider the case where the value, like why would this truly be 1? It would be something like this. Or 2 negative ones. Okay. So I was going to propose to basically just ignore cur non-zero product if it took a value of 1. Maybe I can do that. So cur product initialized to 1 and then -1. Yeah, this is going to have the same cheating property, that it's going to tend to take a value of 1 illegally. So there's really 2 big cases here. One case is where there really is a minimum of 1. And I think we can handle this with a simple Boolean. So we just need to track the all-time. So there's the all-time product max. This is the all-time product max. So here's the all-time product max. And then this is the all-time single max. Okay. Not sure this is optimal, but in this case, what this will do is we can just look at the all-time single max and determine whether it's at least 1. If it is not at least 1, what do we get out of that? What I'd like to avoid, but I might have to do it, I might have to count even and odd negatives. Okay, let's not initialize it to 1 because that's going to have this cheating property. Let's initialize it to nums 0. And we know that, so there is an edge case, right. If nums.length is exactly 1, return nums 0. Cool. To do if needed we can contrive other short circuits, e.g. if length 2, all positive, all negative, or zeros. Okay, I think those are going to be edge cases that we don't need to explicitly handle, but maybe it'll end up being helpful. Okay, so we decided to initialize to nums 0 instead of 1. And we're doing this so that we don't have to like have special handling to like check this thing. We don't need to know if we ever got over 1. Okay. Check for continuous negatives, can throw a wrench in. Yeah, that's fine. Another edge case is zeros. I think we're handling all of these cases in a really simple way, unless I'm missing something. So the case of 0, 0, now we're initialized to 0, and we take the max curve product, curve value. So it ends up being 0. So we don't mess represent by saying 1. Okay, now what about this one? We start with 1, it ends up being 1. We start with -1, and then we consider, should I take the next product or should I take the current value? So we pass all these cases now. -2, okay, and then we consider 6, get it, 12. Now we consider 48. This is where it still becomes a trap because we want to say, the current algorithm will say prefer 12 over -48, but we actually want the -48 because we got this -5 hanging. So this is where we have cur non-zero product. And then we just take a 3-way maximum. What are you writing today? So damn insane. Hey, I'm just grinding Leetcode today. So we're currently doing number 152, maximum product subarray. This is from the blind 75. Blind 75 are like the go-to Leetcode questions. And so we're like right there, just doing them from top to bottom. Interview prep, baby. Okay, so returning to this. I walked through, so we want to walk through this case now that we have the cur non-zero product. So we initialize it to -2. And yeah, as long as it's not 0. Okay, so this is where this is cheating. I can't just set it equal to 1. What can I do here? If current value is 0, I think I need to set like a must reset flag. At least that's the tack I'm going to take for now. So I'm going to say current non-zero product should reset. And I will initialize that to false. But here it will be true. And then the reset condition is, so okay, so if we need to reset, then it's basically in a 0 state. I don't need a separate flag. It's in a 0 state. Yeah, I don't need a separate flag because it's already in a 0 state. Okay, cool. So if curve value is equal to 0, just do the regular thing. Do the regular thing, and now the question is, and by the way, we want to take the 3-way max because maybe 0 is the 3-way max. This is looking a lot cleaner. Okay, so the problem is now that if it's 0, it's going to forever be 0. So I need to detect that, and I can detect it because it's already 0. Did you just do any advent of code? Nope, no. Yeah, I don't really do advent of code at my level. Okay, so if this so if it's non-zero, else what if it is 0? We need to check if it's already 0, we need to check if current value is not 0. I can be explicit about that. Sure, let's be explicit. And if it's not 0, I'm going to set them equal. If it is 0, I'll just ignore the rest of the case because it doesn't matter if you set it, reset it, whatever, it's already 0. So here it's non-zero, and then here cur0 non-product is 0. But the current value is not, so we're going to basically reset it. Reset instead of getting stuck on 0. Used it to learn Rust. Awesome. Kudos. Okay, so if there is a cur non-zero product, yeah, we are going to accumulate the product. Accumulate the product even if negative. Cool. So I feel fairly good about this. Let's walk through this test case. So this test case was previously failing. Now we implemented this cur non-zero product, and we're hoping that now it succeeds. So I got -2. I come through here, and this says, so I actually default to -2. So I want to up that I to 1. Good thing we're walking through. So it's already -2. We initialized it up there. Now we have a current value of -3. And so current product is whichever is greater, -2 or -2 times -3. So we succeed and we grab the 6. We grab the 6, set the all-time max, cur product, cur non-zero product, right? So we said, cur non-zero product is going to be initialized to -2. So we fall into this case. So the cur non-zero product is -2 times -3. So they both take a value of 6. The issue that I see is all-time max here. I don't want to initialize that to -infinity because this is guaranteed to be larger than -infinity. So I'll just default to that. Because I'm defaulting to that, I'll leave it as is. Part of me wonders if I can get rid of this guard clause because this loop starts at I1. And so I wonder if it would just like immediately skip through anyway. var really in 2021. Yeah, that's Leetcode. I mean, I didn't write var. It just defaulted it that way. I feel like the makers of Leetcode are Java developers. Oh, thanks for the likes. I got 15 likes somehow. What are you building, Mr. Ray? We're doing a Leetcode. So this is like algorithm interview preparation. All right, so I'm in a place where I feel comfortable running this test. Hey, got accepted. Okay, well, let's fucking send it then. Okay, wrong. So here's the case, 2 minus 5. So we will default all the values to 2, right? Let me know, I'm having the camera pointed at the input, but if the camera pointed at the code is more helpful, just let me know. Right now we're pointed at the input. So default to a max value of 2. Great. Then I get here to the -10. So my cur product will say, hey, -5 is better than -10. But my cur non-zero product will say, let's go ahead and hold on to the -10. Cur non-zero product here will go for 20. So it holds the -10, gets the -2, flips over to 20. Cur product will say, hey, cur product will take 10. So it'll take the -5, then it'll take +10. And then it'll say, hey, compare 4 and -40. And it'll say -4 is better. So it'll take -4 and then -12. Yeah, so looks like my algorithm is wrong because ideally I should grab -2, -4, and 3. Okay, so this makes me think that I should keep track. I should loop through and then create like a binary index that like keeps track of the ones and zeros. Or like the negatives using a 1 and a 0. So 3 negatives, and then you never get good. So this 5, let's say I keep track of the negatives and I have a 1 and 0 indicator of whether, so this would be a 3. Nope, 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 nope. I can't have a rule that just says, like if it's odd number of negatives, then ignore it. I can't do that. Let's see, what about a rule that says, every time you encounter a negative, you need to rerun the algorithm from that point forward. Ew, that kind of sucks. That would take it from O of n to O of n squared. Kind of a brute forcey thing. It would solve this case though. So that is the solution that I've thought of. I'm actually going to cheat in this case because if it is the right solution, I'm happy to code it, but I don't want to spend a bunch of time coding it if it turns out not to be the right solution. So I have an O of n squared solution. So the question is, can you beat O of n squared? I think you can beat O of n squared. I'm just not sure how to do it. let me do one kind of a hack, and that would be here I have cur non-zero product, and I'll have another one which is cur non-zero product off by 1. And so the idea here is that if I have if even and odd is the only determinant, then maybe I can get around it by just having an off by 1. So how would the off by 1 behave? Let's construct the off by 1. Let's construct it to solve this case specifically. So I'm going to copy that, and I'm going to put it by over here. Okay. So we want it to have 2, 4, 3. And so the off by 1 approach, I'll have it skip the first. Okay. Cool. And then the idea would be if you do a 4-way max here, like the off by 1 thing is not always going to work, but the idea would be that like one of these 3 always works. Or so I hope. Okay, so cur non-zero product, and then we have cur non-zero product off by 1. So the way that this works, if cur non-zero product, let me just basically copy this whole cur non-zero product block, and we will have a cur non-zero product off by 1. If cur non-zero product off by 1, hey, good evening, Kenan, what's going on? Thanks for coming by. Accumulate product 1 step behind cur non-zero product. Okay, so if cur non-zero product, let's see, how can we do this so that it'll always be 1 behind it? It should always have the opposite sign. So if this is non-zero, and then reset instead of getting stuck on 0, we want that to also be true in this case. So here's the meat of it. So cur 0 product is always taking that product. Cur 0 product off by 1, we want it to be the opposite sign. So let's say cur non-zero product went negative, okay? Then this guy should remain positive. So let's grab this one. Okay, so if cur non-zero product is greater, or if it's greater than 0, if it's greater than 0, then we will multiply these guys, yeah? Let's see. So in this case, the off by 1 case, boom, now it's at negative. Now cur non-zero product becomes negative 10. But I don't want cur non-zero product off by 1. I don't want it to take the negative 10 yet. What do I want it to take? I want it to take the value of cur product. Accumulate negative product possibly. Accumulate possibly negative product 1 step behind cur non-zero product, opposite sign. Okay, so here we got this else case, and we will just set it equal to the current product. Okay. Let's see. This test is not right. Accumulate possibly negative product. No, that logic is not right. So let's reset this back to just doing what cur non-zero product does off by 1. So their values should be equal in this implementation. Thanks for the follow. So their values will be equal in this implementation. Minus 10. Yeah, I can just set a flag. Let's see. What if I just set a flag? Okay. Let already encountered negative. Already encountered negative. So we'll say has one negative product. One maybe negative product. That's going to be false. Has one maybe negative product. Okay, so here we'd set it true. Let's say skipped maybe negative product. So if we have skipped it, then we'll continue this operation. Else, or I don't even really need to say else. I can just say this is true now. Okay. Cur non-zero product off by 1. If we skipped maybe negative product, which is false by default, so that will happen exactly once. Cool. All right, let's step through this case. So the off by 1 case, 2 minus 5, here it is. So we start with 2, and then we go to negative 5. Cur value is negative 5. So cur product would be negative 10. Compare negative 5 and negative 10. We'll say negative 5 is better. Cur non-zero product will retain negative 10. But it seems that cur non-zero product off by 1 will just retain the value of 2. That seems invalid. It needs to take the minus 5. So if cur non-zero product off by 1, So I will set it right there. Okay. So that time when it skips it, what value does it take? It can't just retain the 2 and literally skip the 5. Then it won't be a contiguous subarray. So I will have it adopt the same logic used by cur value. Cur value used by cur product. Yeah, it'll basically snap to the value of cur product. Do I want it to snap to cur product or do I want it to snap to cur value? In this case, they're equal. Can I imagine a case where they're not equal? What if this was 1? Then it wouldn't be negative. Okay. Can't really imagine a case where they're not equal right now. All right, so we'll run this. So that was accepted. That's good. Keep it up, bro. Awesome. Thank you so much. I appreciate that. And thank you for the likes. 22 likes. I don't know where they all came from. So we'll submit this. So that's a wrong answer. So, wow, even in our test case that we literally just addressed, didn't we just address this one? Okay, so I designed this to specifically address this. So I messed something up. Clearly. Let's console.log. I think my cur non-zero off by 1 thing, I think I might have goofed it up. So we'll run this debugger. Okay. Step 1, we get 6. All-time max is 2. Why is all-time max 2? Just because we ran the console.log before that line. I'm going to do that after because that's going to throw me off. So we'll run it at the bottom of the loop. Okay, so current product is 6, all-time max is 6, non-zero 6. Off by 1 is 6. Great. Now, yeah, the non-zero off by 1 is not doing, it's not doing the off by 1. Okay, so cur product is minus 2. Right, because minus 2 is less negative than minus 12. So cur product is there. All-time max is still at 6. The cur non-zero product is minus 12. Cur non-zero product off by 1, I expect it to take a value of minus 2. I expect it to take a value of minus 2. And why would I expect it to take a value of minus 2? Where in the code will it be traversing and navigating? So I do expect it to come here. And then I expect this to be false, so I expect to hit this one. Okay, so it is failing to hit this one. So in that case, it should take a value of cur product. Should take a value of cur product. Yeah, so it's not doing that. Okay, why? Seems like it's coming here. Let me just put 0 here and see if it takes a value of 0. Yeah, so it's taking a value of 0. So it's acting as if skipped maybe negative product. Yeah, okay, that's right. So this flag change is in the wrong place. I need that flag change to be if skipped maybe negative product. I need this flag change to be up here, actually. Yeah, need that flag change to be up there. And then if this resets, I think I want to rename it to be less confusing. So let's call it should skip, should skip. Let's call it should skip maybe negative product. And we'll initialize it to true. Okay. Okay, so whenever cur non-zero product is reset, we want the off by 1 to also reset, but then to have this should skip thing. And then we'll set it to false. I think I need to take this block, cur product cur. Yeah, I need to take this block and put it in after. Because I want that flag to still be in a true state the first time, and then it can be in a false state the next time. Okay. Skipped. So this should say if should skip, if it should skip, and we flip these. I might have just like made that a little more complicated than I needed to, but the variable name was throwing me off. So should skip maybe negative product. We should skip making it maybe negative, and that is we just accept the current product approach. Okay, so let's run this code. This was accepted. Now what do I see? I see 2, 6, and then here it is at 12 again. If I should skip and it defaults to true, good luck with the leak grind. Thank you so much, Vincent. Good to see you. Yeah, this false is being incorrectly set. Still the issue. So this is not the condition. So when do we want to stop skipping? This is the wrong condition. We want it to stop skipping. Oh no, that's the right condition. Once we have a maybe negative. Cur non-zero product. Let's condition this on the cur non-zero product is less than 0, so that it's actually going negative. Does that do what we want? Now we have the cur non-zero product off by 1 is -2, and whereas the other goes to -48, it becomes 8. Okay, let's go with our off by 1 test case. So 2 minus 5. Can I do like a custom test case here? Your input. No. Okay. Use example. Whew. Okay. I guess I can do my own test case. Off by 1 test case. Let's do this. Your input. 1, 2, 3. I think it did something wrong. 1, 2, 3. Yeah, how can I tell it my desired like output? I don't know. All right, let's just submit it. All right, we got the wrong answer and why. Look at all this logging. It's 20 again. So the off by 1 is not working. Can I expand this? No. That'd be great, Leetcode, if you would let me like expand that. Okay, so cur product is -5 because -5 is better than -10, right? Okay, -5 is better than -10. All-time max is still 2. That's correct. Cur non-zero product -10, yes. And then the off by 1 is cur product is -5. So that's looking good to me. Now cur product becomes 10. The all-time max cur non-zero product. So I think I need to reset the cur non-zero product whenever it hits positive. That could be an incorrect flag state right there. Okay, so now the current product is -4. Yeah, this is an incorrect flag state. So we went -5, and then we went 10, but really I wanted it to be -2. Okay, so how do we write a rule where -2 is better than 10? There's no, like, we should not be reflecting on the value at all. It's literally just because it's 1 behind. It's literally just because it's 1 negative trailing. Okay. Should skip maybe negative product. Again, this variable name is based on our new rule, no longer correct. What we want to say is like already encountered a negative this run, you know, or should init, like should accumulate non-zero product off by 1. I'm going to call it should accumulate off by 1. All right, and here we default it to true. We actually want to default it to false. So should accumulate off by 1 is not a thing we should be doing. And we actually never want to set it to the current product. When we start accumulating it, we want to set it to the current value, even if that value is a bad deal, quote unquote. Yeah, if we should accumulate off by 1, then we are multiplying. If we should not accumulate off by 1, it's just the current value. So it'd be minus 5. Yeah, are there two flags here? There's like should init. Should init off by 1 and already init off by 1. So should init off by 1. This is going to get triggered over here. Should init off by 1. This is true. It defaults to false, right? Defaults to false. This is going to trigger it to be true. Okay. Reset both of these if curve value hits 0. Okay. Should init off by 1, true. And then here, so if should accumulate, that's correct. Else if should init off by 1. So what do we mean init off by 1? What we mean is 2, 5 minus 2. 2 minus 5 minus 2. So I want you to set yourself equal to 2. Okay. Should init off by 1, and then should accumulate is true. So it says, hey, we're on minus 5. Don't multiply. Don't be like, because like currently this is a value of 5 from last time around. So it's saying don't multiply by minus 2. Set yourself equal to minus 2, but start multiplying in the future. Okay. Should accumulate off by 1. Did I name it wrong? Should and should. So yeah. I'm going to rename it that. Should. And then do I have the word already anywhere? Where is that showing up? Okay. So let's see. So this failed, but it failed on a different thing. Output is 30, expected is 60. So how did I get an output of 30? I got would have reset on the 0, and then I got 1. This 1 is kind of inconsequential. So 2, 3, 5, 2. 2, 3 is 6, 5, 2. 2, 3, 5, 2. Right. So 2 and 3 should have been picked up by everybody. So let's just go make sure, let's scroll down to the bottom, make sure everyone says 6. Cur non-zero product got negative somehow. Whoa, dude, this is really annoying, Leetcode. If y'all could fix that, thank you. Let me actually copy it somewhere else. Okay, so here is the 6's. Cur non-zero product is minus 6. How did that happen? Cur non-zero product is minus 6. All right, here we go. Cur non-zero product actually it seems to okay. Cur non-zero product minus 1, cur non-zero product off by 1 minus 1. So off by 1 thing failed again. it should have gone to 6. Um, -1, -2. The other guy is 2. So I should have a 6 and a -6. But instead I have a 3 and a -6. So this index of 1 thing that I did seems to be like screwing stuff up. Should init off by 1. I mean, let me just do this. I don't know if this is gonna like fix anything, but okay. Boop, boop. And now we're back over here with this problem. Okay, so non-zero off by 1 is 10. Look, they're the same sign. Why are they the same sign? So there's curve product is -5. Okay, that's fine actually. Yep, I think this is an incorrect approach. All right, cool. Well, that was a lot of fun. So I think I need to take a dynamic programming approach. I don't think I can patch it with this like skipping a thing. All right, let's check it out. Brute force, we don't want that. Dynamic programming, oh yeah. Rather than looking for every possible subarray, we can scan the array and solve smaller subproblems. See this problem as a problem of getting the highest combo chain. The way combo chains work is that they build on top of the previous combo chains that you've acquired. Okay, cool. Yeah, it's a gorgeous solution. Look at that. Super simple. So yeah, the intuition is similar, but there's no concern for this skipping. It's just you track the minimum. Um, you track the minimum, and that accounts for the skipping. It feels like kind of like cheating, huh? Because what if it's the minimum and the array is not contiguous? Yeah, I guess the notion is it'll either be the minimum or the maximum because the negative will flip it. So, and there's no fractions. It's not like you have half so that it would turn from like -4 to +2. It's going to turn from like -4 to +8. So then it would be the maximum. And the previous maximum would flip to the new minimum. Okay, cool. Yeah, that's nifty. All right, so let's start this over again. Cool. So we're gonna have all time max. Let all time max equal nums 0. Let cur max equal nums 0. Let cur min equal nums 0. And then do a for loop. Cur value is nums I. Let's see. Cur max equals math dot max of cur max or do we need to know if it's negative? I guess we can just throw them all in there. Math.max of cur max or cur value or cur max times cur value or cur min times cur value. I think it's got to be one of those. Cool. And then for the cur min, we do the min. It's either, it's not going to be the current max, right? That'd be kind of ridiculous. So I really don't, yeah, it'd be the cur min right here. So it's either the cur min or the cur value or the cur max times the cur value or the cur min times the cur value. Cool. We just want the all-time max, is that right? Yeah, max products over array. Okay, so then this is math.max of really, I think we can just return cur max, huh? Okay, let me return cur max. We could do, you know, the maximum of those three, but I don't think we need to. Wrong. All right, well, let's pretend we need to then. It's because of the zeros. Yeah, I forgot about the zeros. Okay. All right. All-time max is max of all-time max, cur max, cur min. That would, of course, be absurd, but anyway. So it's still wrong. Let's see. I said 48. How did I get 48? 6, 12. So like if you just take the absolute value, it's 48. I think I did something illegal. Let's look at this Leetcode solution again. I don't understand why they use temp max here. Max so far. Anyway, so they have, it's the max of the current value, or the max so far times the current value, or the minimum so far times the current value. Okay, yes. But I said it could also be the current max, no? Okay. Yeah, okay, you can't do that. That's how I was cheating. That's how I was cheating. 6. I guess I'd expect 24 in that case. I still don't know how I got to 48. Oh, that's okay. Because current, and then it's being multiplied again right here. Okay. So I can't do that basically. Current value, and this is also cheating. Okay, that's why they have the temp max. Yeah, that makes sense. So const is max per max allowable to multiply. Like, that's just too much. Temp max is the per max that per min is allowed, or like should not multiply. Temp max is the cur max that cur min should not multiply. Okay, cool. So const, whoa, I had like insert on. Const temp max equals math okay. So then now cur min can multiply by the cur max, which is like it's kind of like the previous max, basically. And then we need to initialize the ones. Did that again. Oh, initialize to the 0 index. So here's the cur value. So we start with the all-time max of 2. Yeah. Cur value could be 3 in this case. So temp max should take a value of 6. Let's log them. So temp max takes a value of 6. So all time, yeah, how did the all time max go to 0? What? It's like 6660. How did that happen? All time max. Um, literally does not make sense. Um, oh, because that's like this other input over here. I was just not returning all-time max, the problem. Yeah, cool. Might be. Submit, and then that finally succeeded. All right, we made it. That's a lot longer than it should have. So I think I'm gonna log off for today and rest. Thanks for joining. Talk to you later.